Now we will try to understand convections. So here you can see the definition of the convections. It is another heat transfer mode where the heat transfer or the energy transfer it happens between the solid surface and the adjacent gas or liquid. Okay, so this is, as I said, the convection. But how this process happen? If you look at this animation here, we have a room. We have a lot of particles inside the room. They are moving at the same speed. They have the same energy. Now we put some fire. So this is hot objects. So when we'll put it here, the neighboring particle, they will, you see, it's gradually changing the color. So they will take the heat from this hot objects, and the temperature will increase, and temperature increase means it will be less dense, and due to the less density it will just rise. Look at this. So it will rise like this. So it will be like this. So then once this less dense particle will go up, we'll experience some empty space here. So to fill this empty space, the high dense particle or the cold fluid, it will come this way and it will fill this empty space. Then this cold fluid or the fluid particles, they will again get the heat from these hot objects, and they will become raw. The less dense, they will go up. In that way, this process will continuously, or it will create a loop. It will happen again and again, and in that way, heat transfer will happen between, the hot fluid to the cold fluid. This is called convections. We have a lot of real life applications, and we'll try to understand it later on. So then how we can calculate this heat transfer rate? So previously we used Fourier's law for convection heat transfer. Now for the convection we need to use the Newton's law of cooling. Let's say this is a solid surface, and this temperature is Ts. Here, let's say this is the atmospheric air. Okay, so this temperature will say T infinity. So that means this temperature difference delta T, it is equal Ts minus T infinity. Okay, so this is the temperature difference. Let's say this surface area is As, and another thing is important: heat transfer coefficient for convections. It will depends on the convection heat transfer coefficient H. According to the Newton's law of cooling, the convection or the rate of change of the heat transfer by convection, it will depend on this heat transfer coefficient, surface area, and the temperature difference. And this is called the convection heat transfer, or it is Newton's law of cooling. So now the question is, what is this heat transfer coefficient? This is not the fluid property. It depends on the actually here a couple of things we need to just think about: the surface geometry, the fluid motion, the fluid properties, and the bulk fluid velocity. So we'll discuss these heat transfer coefficients later on. We really don't want to make this video lengthy. So the purpose is like what is convections and how to calculate the convection heat transfer coefficient. So based on the given conditions, I said